All right, hello guys. Let's begin. Okay. Thanks. It's my greatest pleasure to see you here today and to present our latest developments in macros. So, what we're going to be talking about today? Well, first of all, we will cover the new cool stuff that has been developed in Macroland during this half a year after the release of Scala 2.10. The first official release that includes macros. Then we will reflect on our experience and see what macros are good for, what are they bad for, and well, what this entails for their future. And finally, I will present our roadmap, the concrete list of features that we plan to implement like in Scala 2.10, 11, maybe 12. Well, we'll see. Okay, and when mentioning the stuff that I'm going to cover, it's also worthwhile to mention the stuff that won't be covered due to the lack of time. So first of all, macro projects, right? So there are quite a lot of macro-enabled projects, and people use macros for both production purposes and for research. I would love to talk about this stuff. You know, there's a lot of cool things there. And well, unfortunately, I won't be able to do this today. And I encourage you to take a look at the slides, to go to the hyperlinks and see what people use macros for. Right after the talk, I'll publish the slides and well, I'll tweet the link. You can Google me up and well. Okay, so new developments powered by macros out of scope. What else? Yeah, best practices. So well, macros have been here with us in this or that form for like 1 year and a half. Of course, we've accumulated a lot of experience. Well, what you should do, how you should do that, what are the cool tricks, right? And I think it's a good time to codify this stuff and to turn it into some sort of a macro writer's handbook. Again, well, today this session is too short to cover that, but in the middle of July there will be a great occasion, the Scala Peña conference in Tel Aviv, and I'll be presenting exactly that, best practices and advices for macro writers. All right, now without further ado, let's proceed well to the talk. And let's start with a short recap of what macros are in 2.10. Just a quick refresher. A lot of you probably already know that, but I'll be really quick. So, macros. Macros are an experimental feature in 2.10, and this feature it gives you a capability to write functions that will be run by the compiler at compile time. And these functions communicate with the compiler using the reflection API, another experimental feature in Scala 2.10. Okay, and once you hook into the compiler, you can do lots of cool stuff, right? And so there are a lot of macro flavors. But in 2.10, the only flavor is def macros. Def macros, they look like normal functions, except for one twist, okay? When the compiler encounters applications of such functions, calls to such functions, it calls a macro generates some code, and this code gets inlined into the call side. As simple as that. Okay, and this is probably best illustrated by an example. So here we have a login macro, which takes a severity, takes a message, and then generates an if that guards this log, well, so that the message doesn't get evaluated unless logs are enabled. Okay, pretty basic stuff, and let's see how you can do this with macros. Well, first of all, like with everything in Scala, you start with a type signature, right? And type signatures for macros, they're exactly the same as for normal functions. Nothing extraordinary here, right? But interesting things begin when we take a look at the right-hand side. And the right-hand side, in the case of a macro, it's just a dummy that says, okay, I'm a macro. Take a look at my implementation. And implementation is where the real magic begins. So see, it's remember I told about compiler API. So here it is. It's in this context, okay? And it provides an entry into well, this crazy world of Scala C. We'll see a bit later what this entails, but for our simple example, we just need to generate some code. We need to generate an if. So we have the parameters to the log function, and in the macro implementation, they come as trees. Trees, abstract syntax trees that represent Scala code. And as a result, macro implementation also produces a tree. So yeah, here we go. We have some code. We need to produce some other code. How do we do that? And here's how it happens. First of all, we import the Scala API, import c.universe._, and then we use the reify function to compose small parts, some pieces of code, into bigger pieces of code. So as you can see, it's quite easy as it looks here. There are some difficulties. They've been addressed, and just in a few minutes. And for now, well, what are macros good for? Well, obviously, as we've seen right now, they're good for code generation, right? But apparently, they're also useful for a number of other reasons. For instance, you can do language virtualization. Well, there's this cool project called Scala Async, which implements async and await operators, similar to how they're done in C#. Well, in C#, that's a dedicated language feature. But with macros, well, you can implement it as a library. So it just takes normal Scala program, it changes the semantics a bit around this async await calls, and voila, everything works fine. So this is language virtualization. Also, macros are quite useful for type computations. For instance, we have this cool type channels experimental feature in Akka that adds quite involved compile time validation of signatures of actors. So Roland has been able to do pretty amazing stuff. So say you have two actors, okay, and you have type specifications for these actors. So say actor 1 says, I know messages A and B, and I can reply to them with C and D. And actor 2 has the same specification. And now, with macros, at compile time, you can validate that these actors are compatible. That is, that if they start communicating, then they won't get stuck. They will understand each other on every possible step. So yeah, this kind of things, they were usually done and are usually done in Scala with type computations. But with macros, you can do this more reliably and in a more straightforward way. All right, and the final thing that I want to cover in this starting section of the talk is the question that I've been asked a lot yesterday here. So what's the relationship between macros and textual code generation? In my opinion, macros have great potential to supersede code generation altogether. And here's why. Well, first of all, macros operate on a higher level of abstraction. When you do textual code generation, you throw together strings. But macros, they operate on, they have a structured representation for code, this abstract syntax tree, right? And this is more robust, this is more maintainable, and more enjoyable as well. And also, the last but not the least, is that macros, they're friends with the compiler. And so they can ask all sorts of stuff. For instance, what's the type of this expression? Or what classes are declared in your program? And therefore, this gives you more power to your code generators. Well, unfortunately, macros in their current form, they suffer from some limitations that prevent them from realizing the fullest potential. Well, the first limitation, as you guys who might have already written some macros know, they're quite hardcore, right? You need to know a lot of stuff about Scala internals to write complex macros. Well, then, there's another thing, that macros in 2.10.0, they only operate on expressions. So, for instance, it's not possible to take a class, to generate it, put it somewhere, so that it can be seen by the entire program. Well, unfortunately, that's not possible now. But hint, it's going to become possible in like 10 minutes, right? Well, and finally, and this is a very good point, that the code that's generated by a macro, it's transient. I mean, compiler knows about it, but if you want to take a look, well, it's just not there. So there are situations when you don't need the generated code to be seen by the user, but there are situations when you do need that. For instance, for debugging, or for just seeing what it does. And yeah, unfortunately, currently macros don't support that, but we have plans for it. All right, and now, why I'm always saying current macros 1.0? Well, here's why. Macros are moving forward rapidly, and we're addressing shortcomings of macros right as we speak, right? And well, let's see what we have in stock. Macro Paradise. Maybe you guys have heard of it. We've created a fork of Scala to do various cool experiments, and it works for 2.10 and 2.11 alike. And it's binary compatible with the latest releases, 2.10.2 and 2.11 M3, respectively. which means that, well, you can use it for your experiments as a drop-in replacement for respective Scala compilers here. And you can use the libraries compiled for these releases with, with your programs. And finally, it's super easy because, well, nightlies are published all the time to Sonotype, so it's, well, in SBT, it's a couple of lines. So yeah, we have all this, we have this macro playground, and what we have there. Actually, there's quite a lot of features, and I won't be able to cover them all here today. I'll have to stay focused, but well, if you're wondering, you can ask me later on, or you can ask questions after the presentation. So yeah, first of all, quasiquotes. Quasiquotes were implemented by Denis Shabalin, our master student at EPFL. We've had a really great and fruitful collaboration with Denis, and they represent a second-generation tool for working with trees. So if you have programmed macros yourself, you know that reify is the recommended way to compose trees and to generate code. But well, unfortunately, it has a number of problems, and well, we fixed them all. Let's see what this entails in a bit more details. I have 3 points to make. The first one is untyped code snippets. So reify, its a great strength and its great weakness is that it only works for well-typed code. So previously, if we take a look at this example here, right? We want to produce this if, and we know the types of the arguments, so everything is fine because, well, this code inside reify, inside these brackets, it type checks, and since it type checks, reify can do its magic, and it can produce Scala ASTs. But unfortunately, there are situations like here when you don't know the types in advance. So here we just want to generate a type member that's computed dynamically. Unfortunately, that's just not possible. Well, actually, I'm lying a bit. It's possible, but you don't want to know how it's done. Okay, but with quasiquotes, you get this intuitive notion of string interpolation. So you just quote Scala code in these fancy quotes like Q and then quotes, and then you splice stuff in there. And speaking of splicing, it's a bit rough right now. It's quite good, but it's a bit rough. But we have the potential of allowance to splice anything in any place that makes sense. For instance, let's see the next example. Well, in reify, speaking of splicing, of inserting some code into code templates, reify only supports single expressions. So, well, if you need to splice arguments of a macro into some big template, this works. But in more elaborate cases, where, for instance, you generate a list of expressions, and then you want to splice it into a function call, quite natural, right? You have a function call, two arguments, and you have two expressions. Well, that's just not possible with reify, unfortunately. I see this Stack Overflow questions all the time, and yeah, this makes me so sad. But it makes me so happy that we solved it now. You know. So yeah, as you can see with quasiquotes, it's just a splice away. So easy. Well, best thing that happened to Scala macros. I'm dead serious. And finally, pattern matching, right? Since reify is statically typed, it's quite hard to deconstruct statically typed expressions into statically typed parts. For instance, if you have a function foo, okay, well, you have a tree. You have Scala code that is a call of a function. So it's well typed, all right? And now you want to destructure it into a function and into an argument, but you don't know their types. So how do you express that? Well, it's possible, but it's not quite intuitive. But with quasiquotes, just as you compose trees, you can decompose them. So here you just write $foo, $x, and the respective parts would be bound to respective variables. Well, isn't that great? So I would like to once again thank Dennis. It's an awesome project, and I think it simplifies macro development a lot. Okay, the next feature that I'm going to cover, implicit macros. To see how exactly implicit macros are relevant and how they help, and why implicits. Let's go a bit back. Let's make a detour into type classes. So type classes are a very cool and a very idiomatic way of writing modular code in Scala. And well, they're quite popular, used in a lot of libraries. For instance, this example comes from Lift. Comes from Play. That was unexpected. And this type class thing, it works as follows. so say we have a generic function like deserialization here, and that works differently depending on the type argument that parameterizes it. Okay, so one of the ways to model that, to code that, would be to externalize this variant part, this logic of deserialization, this strategy of deserialization into a type class. So here we have reads, okay? And then we introduce an additional parameter to the deserialization function. Okay, everything's cool, it's quite modular, but well, if we would have to explicitly provide the arguments to this deserialization function, it would be a mouthful. But well, luckily with Scala implicits, everything is, well, it's just great, right? You write this serialization strategies once, and then Scala compiler is smart enough to figure out the instances and to fill them in once you call deserialization routines. All right. So just one thing. How exactly you're supposed to write this? Strategies, type class instances, whatever. Well, say when you want to serialize this case class person, then yeah, you just enumerate its fields. You build this deserializer, and all's fine. Except for the fact that you have to do this for well all the classes in your application that you want to serialize. And these classes don't have to be that nice as that one. They don't have to have just a couple of fields, okay? And this quickly derails into a lot of boilerplate. There are solutions proposed by Shapeless and Scala Z, and they're quite cool. I invite you to take a look at how folks do that. But they have unfortunately, they have some performance implications. And sometimes it's fine, okay? And you can get away with it and be super cool, right? But sometimes when your serialization is performance critical, it just doesn't work. So you're forced to write this again and again. And here's where macros can help. Not implicit macros yet, but just macros. So look, instead of writing boilerplate, we just invoke a simple macro. And when the macro expands, it gets transformed into this code. Exactly into this code, just like that. And so, well, no edit complexities. It's as if you have written this code yourself, and it just works. No performance problems. That's good. But still, there's some boilerplate, right? This necessity to write implicit vals for all the classes that you want to serialize. And here where implicit macros come in. And they bring boilerplate elimination to the whole new level, like that. This technique has some depth. It has a lot of juice, right? And I would like to cover the details right now, but well, it just won't be possible. So tomorrow I'll be giving a talk in San Francisco, where I'll be going like all in. We'll cover every single detail, everything that we have in stock. And just as with the today's talk, I'll be publishing slides shortly after the presentation, and you guys will be able to take a look. And yeah, I suppose the video will be available as well. And finally, well, I'm always available on Scala internals, so yeah, feel free to post questions. All right, and the final feature of macro paradise that I'm going to be presenting today are type macros. So remember when I said that macros are not very efficient for code generation purposes, are not applicable for code generation purposes when you need to create new classes that are publicly visible outside the macro expansion. And well, type macros provide an answer for that, or at least one of the answers. So here's the canonical example that F# folks are also using, generating strongly typed wrappers from a database. So say you have a database, well, you have tables, columns, and stuff, and now you want to work with it in a strongly typed manner. Well, okay, just like that. So how is it possible? It's possible with a macro. And well, here we have this h2db macro that takes a connection string, and then, well, it just goes into the database, asks it about the metadata, and generates the code, just like that. So it's possible to generate this trait that will contain all the case classes needed to wrap the database data, and it will contain some other stuff that the macro writer can implement. All right, so this is roughly how it's supposed to work. And how do we implement that? Apparently that's really easy, as we're going to see right now. So first of all, we write a signature as usual. So you can see here that the syntax of Scala has been modified a bit. So currently we cannot have value arguments for types, but for macros this makes sense. So we allow that just for type macros. And then after the signature, we just implement the macro that does code generation. So how does it look? Okay, it just takes a connection string, and then it invokes some function. So macros can do arbitrary logic, they can do I/O, they can talk to databases. Some people might say that's dangerous, sure, but okay, there's no need in buts. Okay. All right, so here we have this function generate code that takes a connection string, talks to the database, and produces class defs, traits, and well, all this good stuff. Okay, so we have this code. Now we call this new function introduce top level that inserts generated code into the compiler's symbol table so that everyone in the program can see it and can refer to it. And finally, once we introduce this, once we edit this class, we just refer to it and say, all right, here we go, compiler, please use it. So it's really as simple as that. Well, sure, I didn't include this generate code function, but it's more or less straightforward, especially with quasiquotes. All right, now this concludes our tour of Macro Paradise. And as you can see, it gives home to a lot of interesting features. And what's even better about it is that everything that we write in Macro Paradise, it's always targeted at Scala, at the upstream Scala. So every feature that we do, we immediately think how it will fit into Scala. And well, yeah, how it will fit into Scala 2.11. Let's figure out. The future of macros. So we have just been in this macro paradise, the nice land where you can hack features and not worry about all the problems, right? But to figure out what's the future of macros, we need to take a step back and see how macros worked in 2.10. So as I alluded before, macros work really nice. They have proven to be useful in a lot of projects, both in TypeSafe, in EPFL, and just people who write Scala, right? But on the other hand, the more macros we write, the more things we notice, things that we don't exactly like. So first of all, as I have mentioned in the very beginning of my talk, well, macros don't require a PhD in compilers to write, but they require, well, some knowledge of Scala internals. This can be annoying at times. Secondly, macros can do a lot, but on the other hand, they're really volatile. They can do a lot and they're unpredictable, right? So, for instance, there are all sorts of tricks to refine the return type of a macro so that it can return something useful that you can rely upon. And, well, yeah, it's all cool on the one hand, but on the other hand, it really prevents both tools and humans from understanding what you write. So this brings like cryptic code to a whole new level. And we acknowledge this as a problem. And just in a few minutes, you'll see how we plan to address it. We take this really seriously. All right. So what's the problem that we arrived at? So macros are dangerous, but they're so cool that we want to have them in Scala very much. What do we do with that? And here's our plan. Well, first of all, having outlined the difficulty of macro writing, now I gladly mention that we plan to remove all these problems. The first step were quasiquotes. Well, you guys who have already written macros and complex macros, you know how painful it is when reify doesn't work and when you have to generate trees all by yourself manually. It literally gives rise to these listings, and it's completely impenetrable, right? But with quasiquotes we make sense of this. And macros in Macro Paradise, they become so much simpler. It's unbelievable. I was on both sides of the fence because for one macro project that I was involved in, I had to use reify for some time. And well, the contrast is radical. And this is only the first step, because we're also looking to simplifying the reflection API, the API that you use to talk with the compiler. And well, yeah, is going to become better. The second step, when I mentioned that macros are volatile and dangerous, it was actually not the entire truth. Because, well, we really have a stable subset of macros that are well behaved, that are friendly to the IDEs, and yeah, why not take them right now? If you want macros so much, why not take them, and why not make them a part of Scala? Why not put them into a language spec? And yeah, this is what we're planning to do. And the rest, the more dangerous macros that we haven't been able to tame for now, well, they will remain in Scala as experimental features. I think that's quite a nice plan. And well, how do we split this good macros and bad macros? This was a topic of really hot discussions that we had internally for the last couple of months. But I think we've arrived at a really simple and clean solution. So what's the main source of problems with macros from the compiler standpoint, from the tool writer standpoint? Well, the main problem is that to type check some programs, you need to expand all the macros that are there. So let's take def macros. So def macros, they mask themselves as functions, just normal functions. You write a function signature, you say it's a macro, and everything's cool. Well, not exactly, because the macro expansion, it can lie. It can, macro can expand into an expression that has more specific type than what was promised by its signature. And therefore, if you rely on this feature, you suddenly find, for instance, that in IntelliJ, which doesn't support that, you have a lot of squiggles, you have a lot of errors in the code, which are spurious. But yeah, so and that's really a problem. And another facet to this is that if you have some code analyzer, all right, that only know about regular functions, it also cannot deal with macros because they can do all sorts of cool stuff. And that's the gist of it. We split macros into black box ones and white box ones. Maybe you've heard this stuff. Maybe you've overheard some conversation, or maybe you've been sifting through Scala internals. But anyhow, here's what they are. So black box macros, they don't need to be expanded for the program to type check. And therefore, they're sort of opaque to the typer, so hence the name black box. Okay, they're just black boxes to the typer. And then, after we have figured out such well-behaved macros, well, it's no problem to treat them as normal functions. Everything's cool. And this is something that we're, well, more or less confident about putting into the language eventually. And here you might ask, okay, why I have gone into a lot of details about cool stuff that macros can do, and now I say, okay, let's satisfy ourselves with the black box macros, and well, okay, because there's the rest, white box macros. They are not going anywhere. They're not going into the language spec right now, but they will hang around as experimental features. And that will allow us to experiment and to innovate a bit more. Well, that's all that there is to it. So first of all, as I've alluded to, and I would like to explicitly state this right now, our goal for macros, our primary goal for now, is to make them simple to use, so that there are no cryptic compiler messages, so that you don't need to know how Scala C works. You just use them. And this is our primary goal for now. And then, in the meanwhile, we will also be doing all these cool experiments in Macro Paradise. And I'm sure that in the next year, I will have some more stuff to present. So don't be discouraged by this direction of development. Okay. And now, finally, it's the time to announce the roadmap. It was posted on Scala internals a week ago, so I don't spill any secrets here. But I thought that it would be great to put it into one place so that there's no confusion. First of all, macros in 2.10. Macros in 2.10 and the underlying reflection API, they don't go anywhere. They stay where they were, and well, we won't touch them in 2.10. But on the bright side, we have managed to snuck in some features. So for instance, the recent 2.10.2 release, it contains some subset of implicit macros. We have been using it to great effect in the Scala Pickling project that Heather will present in the afternoon. Be sure to attend. And well, you can use them right now in 2.10.2. Well, yeah, that was unexpected even for me. And also, speaking of quasiquotes, there's some technique to enable them in 2.10. So if you have been writing big complex macros for which re5 doesn't really work, you will probably be glad to hear that. Please ask me for details if you're interested, and I will gladly tell how it works. So the bottom line is that you can really use quasiquotes in your 2.10 macros, and then you can use your macros with the Scala compiler 2.10.2. So you don't have to use macro paradise or whatever. So yeah, everything's fine, except for one detail. And yeah, that's what we'll figure out later. Now 2.11. What happens with macros in 2.11, which is scheduled to be released in January of the next year? Well, tentatively, right? So first of all, as I said, we are going to make macros really simple to use. And for that, we are going to figure out a subset, a stable subset of macros called black box macros. And this is the stuff that we hope to completely stabilize in 2.12. And in 2.11, we will promote them as the way to write macros. But on the other hand, we will still support white box macros as experimental features. So if you write them right now, you can write them. You can continue writing them in 2.11. But please know that black box macros are an officially endorsed way to write macros. And well, what's the rest? What is the feature that I was introducing today that didn't get into this list? Well, type macros. Sad times for us. I was literally begging Adrian and Martin, please guys, well, this has to be in Scala 2.11, and they said no. But don't worry, we have this nice macro annotations thing here. Yeah, and yeah, when I found this out, that they're not opposed to macro annotations, I was super relieved. You know, yeah, sure, I can place this thing that I'm depressed about type macros, you know, to get some sympathy and stuff. But well, macro annotations, yeah, will bring us there. No problem. So, just to sum it up, we like macros a lot, and macros are here to stay. And to make sure that this is going to be done the right way, we're taking the simplicity of macros very seriously. And this is our top priority now. Nevertheless, this doesn't preclude our experiments. And I have some features for quasiquotes in mind for maybe 2.12. Of course, they will first appear in Paradise, and we'll see how it goes. And yeah, some of the experiments, they're experiments. And so some of them, they are bound to fail. And type macros, they just didn't fly. Nevertheless, we acknowledge the concept of code generation. We understand that there's big need to generate new classes that are available to your program, to add methods to existing classes using macros, and we will find a way to satisfy this need. I will do my best. Well, we have covered quite a lot, and I'll just like to summarize what we heard today from the just high-level view. Well, first of all, macros 1.0, they have proven to be really useful, both in research and in production. And well, after the release of Scala 2.10, we've forked the compiler, and we continued to play with other macro flavors. We've come up with a lot of insights, and some of these insights are going to be brought into Scala 2.11, and some of them hopefully will make it into Scala 2.12. So yeah, this can also be reformulated in different words, and yeah, I appreciate if you get the reference. Thanks, guys. Please.
Have you given much thought to incremental compilation of macros and determining if a macro can depend on anything? And does it just suddenly become full program compilation?
Okay. So the question was, what macros have to do with incremental compilation? Are there any problems? Well, sure. On the one hand, because macros expand into arbitrary code, it's impossible to figure out what they can depend on. So yeah, this is a tough problem, and for now, I'm not quite sure how to address it. On the other hand, integration of macros into existing tools like SBT, it can and it will be made better. Say for instance, well, maybe you remember that def macros, they are split into two parts: the signature and the implementation. The tree manipulation function. So currently SBT has problems figuring out that if we modify the macro implementation, we need to recompile all the files that depend on the macro expansions of this macro. And I think, I'm not sure, Mark probably could elaborate, I think this is something doable. So could you please comment?
Yeah, there's kind of a fundamental trade-off. In theory, a macro is arbitrary code executing at compile time, and in theory, if any of its dependencies change, you might have to rerun that macro because it might generate different code. I think the trade-off will be to just, if the macro itself changes, then recompile things that use it. But I think you're always going to have a little bit of inaccuracy that you're going to have to worry about. That's my current opinion.
Okay, please.
I was doing a play project and using the JSON abstraction that you showed earlier. And after having done the lift project, the single line JSON stuff, case classes, I'm interested to know about performance hits, performance issues maybe with the JSON case class stuff. And then now, if I understand correctly, we no longer have to do as much boilerplate. But we still have to do something behind the scenes for each type, or not anymore.
So could you a bit reformulate the question, maybe?
Okay, what I'm trying to say is maybe, can I do a single line, JSON to case class with hierarchical extraction as well? So I've got a list of things inside a case class, and I can do a single liner in lift, JSON module, and that's my current library of choice.
Okay.
Should I switch to what's coming up now, and is it faster?
Well, it really depends on the implementation of this thing. So as I would imagine, what's typically done here is that the library defines some universal representation for types. So it sort of establishes a mapping between case classes and, say, maps from strings to any, right? And then once you have this uniform representation, then you can write a function that processes like all possible case classes. It just converts them to the representation, and then it does something to them. So this can work fine, but this conversion is, well, it might be a performance problem. Yeah, right. You want to add something?
Yeah, I wanted to add, there's been some discussion on the list about using macros for lift JSON. So I know Joni's working on it. We have with 2.6 have the supporting Scala 2.9 and 2.10, and we also have lift 2.5 was released as final a couple weeks ago. 2.6 is going to be supporting Scala 2.9 as well as 2.10. So we can't use macros there. Lift 3 is going to use macros for JSON stuff. Joni Freeman, who does the macros, who does the JSON stuff, cares more
still be putting my lift JSON into my play project. That's not
That is highly recommended.
highly recommended.
Yeah, please go ahead.
Just focusing on the features that are coming in Scala 2.11, you mentioned macro bundles and macro annotations. I'm not sure, I might have just missed you cover what those
Okay.
are. Are macro bundles just select macros that were
All right.
listed?
So as I mentioned, I wasn't able to cover everything like that I would like to do, but well, so answering your question, macro bundles, they're just a simpler way to write macros. So if you go all the way to the beginning, like here, so see here when you write def impl, you have to have this context. You have to declare this context, and then you have to carry it around because the types of artifacts that macros operate with, they're path dependent. So they're bound to this concrete context. And then when you, for instance, want to modularize your macro, if it becomes too big for a single function, then you find yourself in a trouble because you have to carry this context around again and again, like in every helper. There are some techniques, workarounds for doing that. But with macro bundles, it becomes much simpler. Well, what macro bundle is, it just inherits from a trait that's called macro. And this trait has a single member, C context in it. So, and then everything becomes like implicitly path dependent on that context. Implicitly, not in the sense that it's done with implicits, but it just it is much simpler to do that kind of stuff. And then all the methods inside this trait, they sort of refer to the same context, and you don't have the path dependent problem. So macro bundles, they're just a convenience that we've come up with to simplify macro writing. And speaking of macro annotations, well, macro annotations can be viewed as regular annotations, so just as things in Java and in Scala that you put on classes, methods, and stuff, but they're sort of active. So they are linked to the code that's executed at compile time. For instance, if we take a look at the type macro example here, yeah, here we say object.db extends this type macro, and it generates code. This can be reformulated in a similar way with the macro annotation. So you just write object.db, and they say at h2db, and then provide the connection string. And then this annotation macro expands. It can do some stuff to the member it's annotated on. So I hope this answers the question. Yeah, please go ahead.
So I guess, like, as fun as macros are, or when you screw up, sit there banging your head against the keyboard for a while, is there any plans on like making them sort of explorable, like being able to write like a very specific like unit that's like, hey, I want to make this so I can catch all my non-ask mistakes?
Okay. Well, that's a good question, and it has multiple answers. So, indeed, it's currently really tough, and I'm not aware of any representation for now, any implementation of that for now. It's really tough to write unit tests for macros. So, I don't know, just write a function that takes some sort of a macro context, some sort of a mock macro context, and then expand the macro using that context. Unfortunately, that's impossible. Well, that's not impossible. That's tough to implement because macro context is rooted into the Scala compiler. So essentially, it's a window into this huge beast, right? And it's quite hard to mock it. But on the other hand, there's a really neat trick that obviates the need for mocking. Well, it's a workaround, but in practice, it works quite well. So with the Reflection API, another experimental feature in 2.10, we introduced these toolboxes. Which can do runtime compilation. So you have an AST, you give this AST to the toolbox, and it runs it. It evaluates it. Okay. So this facility can be used to unit test macros. So you just write a string, or with a quasiquote it's even simpler. You write a quasiquote that features the code that you want to test, and you give it to a toolbox, and then you observe the results. So this is, for instance, how Scala async works. And Jason and Philip probably are going to elaborate on that today. Yeah, please.
Can you use macros to verify that an actor closure doesn't reference parent scope?
Well, probably that's something that Heather will answer. Please, could you comment on that?
I guess it would be covered in the talk. This idea of using macros to sort of protect the environment that's captured by flow use. So that's something that's coming.
So bottom line is that it's possible, and it will be shown this afternoon. Yeah, pickles and spores. This is the name of the talk. Okay, do we have some more time? Do we? Well, actually, I think just for one more question. Okay, please, Eugene.
So, in the paradise macro, if you use this type of thing to generate type, can that still be used by the regular Scala? So, can I generate like the type macros using the paradise?
Okay.
And then, can that jar be bound to the regular Scala too?
Oh no! Unfortunately, it doesn't work that way because it requires modifications to the type checker.
Okay.
So it really ought to be macro paradise. But this is how quasiquotes work in 2.10. So quasiquotes, you can compile macros that use quasiquotes with a macro paradise build, and then you can use the result with vanilla Scala 2.10. So this neat technique is described in our documentation for macro paradise. Well, all right, then thank you guys. We're out of time.